A very good day, everyone. My name is Ragunan, son of Sandran. My ID is 532131210028, and I'm from class 5 BAB. Today, I would like to present regarding assignment 2 from embedded system. The objective of this assignment is to work on temperature sensing with LM35, switch and LED using if, else, and millis. Learn how to interface an LM35 temperature sensor with Arduino, and to use an LED and a switch in conjunction with the LM35 sensor, implement an if-else conditional structure to control the LED based on temperature, and to use millis for non-blocking timing instead of delay. So the first exercise is to use analog read serial. So once we upload this data, the video of the analog read serial is here. So the value will be ranging from 0 to 1023. So now the value is showing 1023, and when we turn the potential meter to the other end, it will slowly reduce to a value of 0. So now the value indicating 0 on the serial monitor. Then when we turn to the other end, it will again show 1023. Okay, moving on to the next slide. So as per the instruction, this is the schematic diagram of the circuit, and this is the pictorial diagram of the connections. So this is the video of the analog read serial when we replace the potentiometer with the LM35 sensor. So once we fix it, the value indicates between 40 to 70. So in my case, it's approximately 49, 50, 51, 52. Okay, and the exercise on the tutorial is to read the temperature from the LM35, turn on an LED if the temperature exceeds a threshold of 30 degrees, and use a push button switch to enable or disable temperature monitoring, and use millis to check the temperature periodically without blocking execution. So this is the coding for the Arduino, and this is the video of the uploaded coding, in which case the button will enable and disable the temperature monitoring. So when we press again, it will stop monitoring the temperature. And again it is pressed. Okay, moving on to the next one is the assignment question. Question number 1 is to explain how the LM35 sensor converts temperature into voltage. So LM35 is a precision temperature sensor that converts temperature into an analog voltage output. LM35 generates an output voltage that is directly proportional to the temperature in degrees Celsius. It is pre-calibrated to provide a sensitivity of 10 millivolt per degree Celsius. Voltage output can be read by an ADC, in which it is called as analog to digital converter in a microcontroller. In our case, it is an Arduino to process and display temperature values. The temperature value is as per the formula given. Question 2 is, what is the purpose of Millis function in this project? The Millis function is used in this project to track elapsed time without blocking execution. Instead of using delay, which pauses the entire program, Millis allows the Arduino to perform other tasks while waiting for the next temperature check. And non-blocking temperature monitoring. The temperature is checked every 1 second, which is 1000 milliseconds, without stopping other parts of the code. This ensures that the button press can still be detected while monitoring other active state of the button. Question number 3 is, why do we use an input pull-up or pull-down resistor with the switch? When using a push button switch, the Arduino needs to reliably detect high and low state. However, when the switch is not pressed, the pin is in a floating state, meaning its voltage is undefined and can randomly fluctuate. This can cause false detection or unstable readings. To solve this, we use pull-up or pull-down resistors to ensure stable default state when the button is not pressed. So the fourth question is to modify the code to blink the LED instead of turning it on continuously when the temperature exceeds 30 degrees Celsius. So this is the coding, and this is the video of the uploaded coding on our Arduino. So we can see that the LED is blinking when the temperature is exceeding 30 degrees Celsius. Moving on to the next question is to implement an additional feature to display a warning message on the serial monitor when the temperature is too high. So this is the coding, and this is the video of uploaded coding. Now it is blinking, and it will indicate on the serial monitor as warning, high temperature detected. Moving on to the next question. How would you modify the code to adjust the temperature threshold dynamically using a potentiometer? So in this case, I've used the A1 to connect the potentiometer, the A1 as the port pin. And this is the coding and the video of the uploaded coding. So in our case, I set it from 30 to 50. When the temperature exceeds 30, then the LED will blink. If it's 30 or less, the LED won't blink. Now it is 30, and when we increase it back, it will start to monitor again. Okay, number 7. What advantages does using millis have over using a delay in our coding? So the advantage of using millis over a delay in our project. The millis function provides a non-blocking way of track time, whereas delay completely halts the program execution. This makes millis much more efficient, especially in the projects that require multitasking. Second one, Melis allows multitasking and non-blocking execution. Delay blocks the entire program, preventing other tasks from running. Melis, on the other case, allows the program to keep running other tasks while waiting. Melis makes the code more responsive. With delay, the system ignores new inputs while waiting. With Melis, it can detect and react to button presses, sensors, and any changes, even while tracking the time. Next, Melis also allows accurate timing for multiple events. Delays only manages a single time delay at a time. However, Melis allows multiple timed events to run in parallel. Melis also prevents freezing and improves power efficiency. Delay stops the whole execution completely, making the system unresponsive. Melis allows smooth operation without freezing, improving real-time performance. So next is to modify the code to display the highest recorded temperature since the program have started. So this is the coding, and this is the video of the uploaded coding, and as you can see, the serial monitor is recording 37 degrees Celsius, which means that is the maximum temperature that it has sensed since the start of the program. So next one, we go to the ninth question, is to modify the code to include a buzzer that turns on when the temperature exceeds 35 degrees Celsius. So this is the coding, and this is the video of the uploaded coding. So as you can see now, I'm turning to let the alarm to sense temperature more than 35 degrees Celsius, and the buzzer is now working. Now it is indicating approximately 37 to 38 degrees Celsius. The buzzer is working, and when I decrease back, there's no sound from the buzzer. So the last one is to modify the code to turn on the LED only if the temperature remains above 30 degrees Celsius for 5 consecutive seconds. So this is the coding and the video of the uploaded coding in our Arduino. Now it is indicating 20 degrees Celsius. When I increase back the temperature, it sounds the buzzer and the LED will come after 5 seconds. Then LED is now turned on, and now it's indicating 37 degrees Celsius. And that's all from me. Thank you.